Welcome back, everybody, to Spring One. I keep saying it, I'm so excited, but it seems like as the day goes on, I get even more excited with each additional topic. So, the next talk that I'm just so looking forward to is live coding Spring data queries to the end of the persistent universe. And it is brought to us by Greg Turnquist. Take it away, Greg.
All right, thanks. I'm glad to be here. I'm gonna switch on my slide deck here, and for a little bit of a warm up, and then let me hit the share button. So we just have a handful of slides, and then we're going to jump to the actual live coding. Now, I hope you were able to catch Christoph's presentation earlier about a Spring Data's guide to the persistence. Uh, um, and this one, we're going to take that stuff and we're going to go write it by. We're going to do it by real live coding. And just as a quick intro, who am I? I'm a Spring team member. Specifically, I work on the Spring Data team. I'm an author. I've written several books on Spring Boot. Just go check that out. I also run the Spring Boot Learning YouTube channel. I'm a coffee drinker, and I'm a dabber. I had this theme going, and that sounded neat when I wrote it down on slides. So you tell me if that's a good joke or not. So I hear that you want to write some queries. You want to query some data and get an answer to an all-encompassing question. I don't know what the answer to life, the universe, and everything. Maybe not that big. So what are you going to need? First of all, have you seen Spring Data's Guide to Persistence? If you caught it this morning, awesome. If not, be sure to check it out on the replay because this presentation and Christoph's is meant to go hand in hand. So you can take a peek at that when you get a chance. So if you're all prepped up, then go and grab your towel because we're going to code enough queries to hit infinite improbability. Time for some live coding. I'm going to pivot to where it's sharing just my IDE here. Okay. All right. Now, I love to start any presentation with something like, let's go to start.spring.io. That's how Josh does it. It's awesome. But we actually have a finite amount of time to get to infinite improbability. So I can't start there. So I've actually preempted this and created a nice little set of entity objects. We have an employee object here with a name, and we also have a manager type, sort of a one-to-many relationship here mapped out. Now, if you're wanting to know more of the gut details of how to do JPA stuff, then after this talk, there over on the intermediate advanced talk is something to go into a more deep dive on actually squeezing everything you can out of JPA. I'd go check that out if you want to learn more intimate details about JPA. Here, we're talking about how to query data. And just as the prep here, this is where I have all my little bits of data initialized and stored in an embedded database. Here I happen to have a manager created and a couple employees, and I have them linked together. So one manager has one or more multiple employees. Now, with our little data structure set up, we need to kind of hang this stuff. If we're going to write queries, first of all, we're gonna go create something based around our employee and manager type, and then after that, we're gonna put an API. We're gonna wrap around it. Now, with Spring Data, the idea is to simplify writing queries and get to the business that you're trying to do. So we have here is what's called a repository class, and it's actually not a class. If you'll notice carefully, it's an interface. And with this interface here, we can actually declare declare our operations that we want to query with Spring Data, and Spring Data is going to go write them for us. Now, what we're doing is we're extending a pre-baked interface called JPA repository that comes from Spring Data JPA, and all we need to do is tell it what type does this repository extend over, in this case, our employee type that I showed this, that I pre-baked for this presentation, and what the type of the ID is. In this case, a long type. And here I've got this is an empty repository, or so it seems. But if I go over here and start leveraging this thing, we're going to see what actually we have a hold of. So I'm going to add this particular one to the constructor call. I'll go ahead and add the other one as well. And let's start writing our first API. So we want to just, how about we just start with give me everything. So I'm going to do a list of these employee objects. Just call it all, okay? I'm going to grab this. That's not what I wanted. Let me grab the employee repository, find all. Where did that method come from? That was an empty repository, wasn't it? Not quite. If I open that up, if I use my IDE to navigate it, you'll see that inside that JPA repository that came from Spring Data JPA, there's already some predefined interface operations. There's several finders built in, save operations. Down here, there's some delete ones and ways to fetch, other ways to fetch some basic data. So we actually get something for nothing. And I'm actually going to right here, let's go ahead and get to that first API built repository. So I'm launching the app here. I happen to have some debugging turned on. And when you're writing queries for the first time, I highly recommend turning on stuff like Spring org.springframework.data trace, and you can tell it to show all the SQL. If you use spring.jpa.show SQL, this is stuff built into boot that'll do the trick for you. But now, nicely in my little IDE, I can just jump to a terminal here, and I can curl that endpoint. Now, if I just do that, it's a little hard to read. I like to pipe it through the JQ utility to make it print friendly. And if I scroll it up here, you can see I've already got some data loaded. Right away, we've already written our first query. And how much SQL did we write to do it? 0. The SQL that you do not write doesn't have any bugs in it. Okay. Got that first query done. Okay, now let's go back here and think about what else do we want to fetch. You may want to fetch individual ones, like maybe you know which one you want to get. It's common to somebody provides an ID value and they want to get a single employee. Then again, what we get, find, we have an option here to say find by ID. We can fetch a single one if we know who we're looking for. And by the way, if we have these parameterized types, how am I going to get it to here? I'm going to use a little Spring MVC magic and just use a path variable annotation. Now it's red here. There's something wrong. What is that? That's because it's actually configured to return back an optional because we don't know if there's anybody there yet. So there's a chance that somebody could be querying on a non-existent ID and there's nothing there. So in that case, I'm going to put in an or clause, or else I'm going to throw an exception. There we go. Now I can just restart all that. Let's see what we got. So if I go back to the terminal here, where I did the little curl operation. If you remember, I got all the employees. So I've got, let's look at here. Here's the second ID, this particular user. So I should be able to just go put this in here, go put /2 and get a single user in that case, or single employee record there. So already, without writing a line of either SQL or JPA or whatever query language you're using, right now we're using JPA, but this also works on MongoDB, Redis, whichever data store you're actually using, you're actually getting access to data without having written any code at all. So we can either, right now in our current setup, we can either get all the data or we can get none of the data, or sorry, one item of the data. Sometimes what we need though is somewhere in the middle. And so to do that, we need to go let's go write some more detailed queries. For example, maybe I want to go find an employee based upon a name search. Let's create let's call it, let's do a name match. We want to search based on the user's name. Let's return back a list. search based on name. String name. Okay. In this case, I want to get back. I want to find by name. Uh-oh, we don't have a find by name operation. Time to actually write our first custom finder. Now I'm going to go back over to the repository that we started with, and I'm going to start making, I'm going to spec it out here. I'm going to define that I want to get a list of employees back. And if you'll notice here, right here as I stop, I'm using IntelliJ IDEA, but any modern browser that's got Spring Support built in can handle this. It's actually helping me complete this by showing me what I have access to. Find by name. And I can just do that. String name. So it's saying it's ready to do a perfect match by parsing this operation, and it's going to do an exact match, case included, on the name field. So I should be able to just restart this and get it going. Okay, let's switch over. Let's do that. Let's query that endpoint. Now we have to use an exact match. So I'm going to use a %20 to do a space properly. And if I do that, I can get a particular operator, or maybe I can get back here and look for somebody else. But who wants to escape operations like that left and right? Why don't we make it simpler and instead just do a partial match? How about that? So I can go back here and define a more detailed one. And here again, if I use the IDE, it can help me do a match here. So if I do string, I can do partial match. Containing, in fact, let's add a little bit, find by name. Here, let's do that one. So maybe we're going to call this partial match. Let's make our API operation a little smoother. Find by name containing partial match. So it'll put checks on each end. All right. Oop, I did not mean to hit the debugger. Let's turn that off. Okay. Okay, let's just restart that one for good measure and make sure we don't have any conflicts going on here. Okay. So let's just say I want to search on Baggins. What do we got here? Right away, we have Frodo Baggins and Bilbo Baggins. So we have matches based on that. We could search on Frodo and get just that entry. So now what happens if I use lowercase? Is it gonna work? Is it gonna work? Well, it worked. It just came back empty because it was still checking on the case sensitivity. So let's see, find by name containing, see, ignore case. And let's restart that. Now what happens if I try to search on that lowercase Frodo? What happens when it's going to get me a match? So now in a short span of time, we're able to implement this search function that your manager came in and said, we need this search box. We need to be able to put it up there so people can do partial matches and things like that. So we can do operations. We've got to be able to do that. And something they talked about in the presentation was we need the stuff to flow. We need the queries to flow, and we need to be able to keep you in the developer space. And in this way, we can do that because you're not wasting your time gluing tables together, if you will. Instead, you're able to focus on what do I need to write the code that solves this problem. So let's go write something even more detailed. Now we know that a given employee has a manager. What if you're trying to find, I need to find all the employees based on who their manager is, like you're trying to look up a department. And so, instead of dealing with querying against a single table, you're trying to match based on a manager name. Search based on manager name. Now, we're going to do that. Well, we can go over here to our repository. Amazingly, these queries let you actually navigate across relationships. And so for this kind of thing, I'm going to create a find by manager operation. Let's see. Find by manager name. String name. So when you have an operation like this, it will look at what's the manager attribute of the employee record. It'll see that that's a relationship. It'll cross over to the other side, if you will, to the manager object, and then let us match on the manager attribute, manager.name. And over here, I can then find by manager name. And if I restart that, I can see that, what that gives me. I can spell the name Gandalf. Please. Manager name. Did I mistype something? What? It blew up on me. Proof that it's not. Proof that this is a live demo. Oh. Manage name is not. Aha. There we go. All right, let's kick that one out of the ditch and get it going. So here, let's try to go cross a relationship, a one-to-many relationship between manager and employee, and see if we can find all the employees tied to this particular manager. And here you go, Frodo Baggins and Bilbo Baggins. And if I check against our other manager in the system, Saruman, okay, we get our other employee. And it's neat with those flags flipped on that I just showed you earlier. It really makes it easy. Oh, I'm in the wrong terminal. It makes it easy to go debug stuff because then you can go see exactly what queries are being written to go fetch data in Hibernate. Now the last one, let me see if I can fit in here. I'm trying to fit in as many as we can do here. There's another service that we have. For example, if you're building a search box or like a filter on a website, and you want the user to define everything that they're getting, okay? Just call this a general search. And you want to return back a list of whatever your type is. What you want is what's called an example. Let me show you what I'm talking about here. So somebody feeds in, they can pick any criteria. Request param. Maybe they want to pick the name. Maybe not. Maybe they want to pick the role. Or maybe they want to pick, let's call it manager name, since we've been doing that one. What are we? Oh. Let's call it manager name. And I'm setting these, by default, these parameters are required, but I'm setting them to be optional. Manager name. So what I'm going to do is I'm going to go create an employee object here right on the spot. And I'm going to assign it these values that I came They could be null. They could be populated with values. Let me just check, make sure that's okay. I need to do first. There we go. We'll do that. Okay. So I'm going to populate this object here. It has the name, it has the manager. Some of those fields could be null, some of them may not be. And I'm going to create what's called an example object. And I'm going to then find all, where's the, here, by example, find all based on this probing example. Let's restart this and we'll see what this lets us do. So here's where you're pushing it off to the user to give them the option to do that. What are they going to pick to do? So if I go to the terminal, I can do this. Let's say name equals Baggins. Okay, that doesn't match unless I do that encoding stuff. Okay, so if I do a match on Bilbo Baggins, I get a hit, right? Okay. Or if I do the Bilbo, or if I do Frodo. But I can also change up what I'm doing, and this lets me add other criteria without even having to go write another finder. So if I use manager name equals Gandalf, it finds both of these two. Now there's options to extend this. For example, right now, the query by example option, it's based on what values are not null, but you can add extra criteria like starts with, ends with, ignoring case. I don't think we have time to go into that stuff. I'm trying to keep an eye on the clock here and see if we can fit in one more bit of good stuff here. Let's see if we can do a little auditing. So first of all, I'm going to turn on JPA auditing. We get asked about this fairly frequently about what support we have for being able to keep track of stuff. So I'm going to register an entity listener for my employee object. Let's call it the auditing entity listener. And this is going to let me go in here and say create a date. I'm going to pick a jobutil.date. And let's go add a getter for that. Let's see. I think that's everything that we need in order to demonstrate that. So let's restart the app. Let's go run one of our recent queries. And you'll notice we have a new field down here. We have a create date. It's possible to go register other stuff like who did the creation. There's also, you can do updates. So you can track a lot of stuff directly in the database as to what operations happen. And it really adds a lot of power to all that. What I'm going to do is I'm going to switch back to my deck because I just have a few wrap-up slides here. Let me go back to Keynote. Now, I remember that thing about getting back into the flow. And so with all this kind of stuff, I say the queries must flow, and then you're supposed to say, well, hold on, that what are you doing? I thought we were on a Hitchhiker's theme here. Well, I like science fiction, I like fantasy, and I like comedy. So little Hitchhikers plus Lord of the Rings, throw it in with a little Dune. Why not? So let's I want you to be sure to stay connected. If you want to get more of this content, some of my live streams and stuff, go visit my YouTube channel at Spring Boot Learning. And also don't forget to go catch Christoph's talk, A Spring Data's Guide to Persistence, on the replay when it's posted on September 7th. And then after this talk, if you want to see more core detailed deep dive stuff on JPA, go over to the intermediate advanced track for the next talk that's coming up right after this one. Thanks, everybody.
Hello, everybody. Greg, oh my gosh, thank you so much. Now, I not only want to write more queries using JPA and what's offered by Spring Data, now I want to go watch Dune, go back and rewatch A Hitchhiker's Guide, and read the book. So you have given me so much material to explore. So thank you so much for that presentation, folks. We are now. Oh, folks, I want you to join. Greg now in the Zoom chat. That Zoom chat is link should be in your Slack room. So go in there, click it. Feel free to ask Greg questions about the presentation or anything that you need to want to explore about the queries. And up next is going to be an exciting talk called Beautiful Spring Tooling for the Masses. We have Hadi, Martin, and Sandra going to be doing that presentation. And that will start at 12:05 p.m. Eastern. I look forward to seeing you then. Take care.